Okay, hold it back here just a little bit. Okay, so it needs to go more that way. Okay. Okay. Hey guys, today we're talking about simplifying square roots. Okay. So all this past week we looked at perfect square roots and how you find just the square root. Today we're actually talking about simplifying square roots. So you're going to need to know two properties, which we're going to go over today. One is going to be the product property of square roots, and the other is the quotient property of square roots. But first, I want you to think about something. So when we're doing this, the square root of 9, you now should know, is 3. And the square root of 25, you should know now, is 5. These are perfect square roots. And so what is 9 times 25? Well, that is 225, right? So what would be then the square root of 225? That is 15. So do you notice anything about this? The square root of that is 15. Look over here. 3 times 5 is 15, right? So that brings us into our product property of square roots. And basically what this is saying is that if you take the square root of a times b, that is the same thing as the square root of a times the square root of b when a is greater than or equal to 0 and when b is greater than or equal to 0. Okay? Now, this is the algebra way of saying it because we have our variables here. So this is the algebraic way of defining the product property of square roots. But we can also do this in numbers. So if we said the square root of 9 times 7, that's the same thing as the square root of 9 times the square root of 7. We know that the square root of 9 is 3, and we know that 7 is as simplified as it can be. So our answer would be 3 times the square root of 7. And this is the numbers way of actually finding the product property of a square root. Okay, so what we're basically doing is taking our square roots and we are taking this radical expression and bringing it into its simplest form, meaning there's no more perfect squares left underneath the radical sign. And there's no more, and then also there's no fractions under the radical sign and no radical sign in the denominator of any fraction. Okay? So let's give an example really quickly of simplifying a radical expression. So let's take 180, the square root of 180. That is the same thing as 36 times 5 because 36 times 5 gives us 180. And then that can be broken down into the square root of 36 times the square root of 5. We know that the square root of 36 is 6. And the square root of 5 is going to just be still the square root of 5 because it's in its simplest form. So that is our answer. And we simplified the square root of 180 and it gave us this expression. Okay? Now, if we simplify a variable expression the same way, it's just saying if we have a variable in our radical sign, underneath our radical sign, how will we do that? Let me give you an example. If we have the square root of 24 s to the second power, that is the same thing as 4 times 6 times s squared, then that can be broken down into the square root of 4 times the square root of 6 times the square root of s to the second power. So we know here that 4, the square root of 4, is the same thing as 2. And the square root of 6 is just going to stay the square root of 6 because it's already in its simplest form. But look here, we have s squared and the radical sign. Well, those are the two properties that cancel each other out. So we are going to be left with just s. We're going to rearrange that, and that's going to be 2s and the radical of 6. So that 2s and the radical of 6 is simplified now. It's in its simplest form. And this 24s squared is 2s with the radical of 6. Okay? So one other property I want to go over is the quotient property of square roots. Quotient meaning division, product was multiplication, of course. So same thing. This is saying if we have a fraction underneath the radical sign, just going to use it first in algebraic terms, a over b, and underneath this radical sign, that's the same thing as a over the square root of a over the square root of b. When a is greater than or equal to 0, and when, you pay attention here, b is greater than 0. So that's saying in the denominator here, b has to be greater than 0. It will not work if b is 0. It has to be greater than 0, okay? So this is the property in algebra terms. Let's do one in numbers. So if we have the square root of 11 fourths, that's the same thing as the square root of 11 over the square root of 4. And that's going to be broken down into the square root of 11 over 2. Now this is in its simplest form. Okay, I've got one last example I want to show you really quickly. So if we have the square root of 13 over 36, we're going to break that down again into 13, the square root of 13 over the square root of 36. We're going to use that quotient property of square roots to simplify. That's going to give us the square root of 13 over 6, because we know that the square of 36, the answer to the square root of 36, is 6. Now this expression has been simplified and it is in its simplest form. Okay? So I hope that helps you for today's work, and we'll do some more examples. Feel free to chat with me today if you have any questions doing your work. I hope you guys are having a great day. I hope you're able to learn something today. Bye-bye.